All right, number 13, let f of x equal that. The points A and B are on the graph as shown in the diagram below. Write down the value of B in exact form. So for AI, we're substituting in 2 because that's x that goes with the B. So exact is going to just be that, e squared plus 2. So if we do that in the graphing calculator, you get the value 9.34. Okay, 9.34 to 3 significant figures. Write down, correct to 3 significant figures, the value of f at 1. So for BI, that's double I, f at 1 is e to the 1 plus 2. So, yep, just in the calculator, e to the 1 plus 2 is going to be 4.72. Double I, the value of the inverse at 6. So that's when we set 6 equal to e to the x plus 2. And you can put this in your graphing calculator. Okay, so if you put this in your graphing calculator, your e's over here. Oops, tab. We need e to the x and then plus 2. Oops, plus 2. Okay, so there's that. So you could use nsolve with this, that's fine. And for all these other ones, except for when you want it in the exact form, you can always do graph trace. So if we wanted graph trace for BI, we just put in 1 and push enter, and there's the 4.72. So if we want to do this with the graph, we put in 6, and we can just find that intersection, okay? So left and right. So 1.39 is the answer to that. So x is 1.39. So on the diagram above, sketch the graph, indicate the y-intercept and the horizontal asymptote. So this vertical shift of 2 is the horizontal asymptote. So we'll do that. IB won't always remind you of that, so make sure you put it on. The y-intercept is going to be 3, okay? And you can just do that, okay? Write down the domain, that's all real numbers, and the range, y greater than 2. Okay, so for 14, find the exact solution. So we need to rewrite this. These both are powers of 3, so that's 3 squared to the 2x, and that's 3 cubed to the 1 minus x. And then we can set the exponents equal to each other. That will be 4x on this side, and this is 3 minus 3x. So adding the 3x over and dividing by 7. All right, 15, again, powers of 3. And this one's 3 to the negative 1 to the 2x. So we're going to have 2x minus 2 equals negative 2x. And we'll subtract 2x, and this will give 1/2. This one, powers of 5. So we're going to have 2x squared equals 1/2. X squared is 1/4. And x is going to be plus or minus 1/2. This one, 2. And 2 cubed. So 2x squared equals 3x. And this is quadratic, and we have to get it equal to 0. X pops out. So either x is 0 or x is 3/2. For 18, these are powers of 5. This is 5 to the negative 2, and that's 2x minus 1. So we're going to have x squared minus 3 equals negative 4x plus 2. Quadratic, so we have to get it equal to 0. factor. So x is -5 or x is 1. All right, number 19, for each of the following functions, sketch the graph and complete the table without graphing calculator. So the asymptote is going to be at 5. No, it's not, sorry, that's the y-intercept. So that's when x is 0. So 0, 5. All right, the asymptote is actually at 3. So we'll do a dotted line there and label it. So that's that. Exact value of b, so that's when we substitute in 1. So that's going to be f at 1 is 2e to the 1 plus 3. That's the exact value. We'll leave that. Domain is all real numbers. Range is y greater than 3. So we can just, do like this, something like that, okay? B, all right, so -3, that's going to be our asymptote. Y-intercept is at -1 when we substitute in 0. Exact value of b, that's when we have f at 2. So that's 2e squared minus 3. Domains, all real numbers, and range is y greater than -3. Something like that. 20, consider this function. Write down the domain. We can substitute any number, so it's all real numbers. The y-intercept, if we substitute in 0, it's going to be 15. If we type, okay, so for C, we need to substitute into the graphing calculator. So it's going to be 10e to the 0.3 times 5, and then plus 5. So this ends up being, f at 5 is 49.8. So for double I here, we want 100 equals that, and we can, I'm just going to use nsolve this time. And x ends up being 7.50. For D, find the first integer value of x for which the value of y will exceed 120. So we can do 120 in the nsolve. So that it ends up being 8.14116. So that's when it's exactly equal to 120. So not until after that will you get more than 120. And you can always do that in your, just make sure by substituting in 9. And I would also substitute in 8 just to make sure. So when you substitute in x equals 8, you get 115.232. And when you substitute in x equals 9, you get 153.797. So you can see it's exceeding 120 at x equals 9. All right, find the value of f at -20 and deduce the equation of the horizontal asymptote. So if we type in -20 as our x, we should get 5.02, and deduce the equation of the horizontal asymptote. So what they're trying to do is get you to put in a small value of x. I know that doesn't make sense, but like a very, very small value of x, like -infinity. And if we were to put in like -100, which I know they tell us not to, but we're going to do it, you get 5, okay? So basically, they're just trying to get you to see that as x gets really small, it's approaching the line y equals 5, okay? And we knew that from the vertical shift, okay? Now, the range of f is going to be y greater than 5.